Hello, this is Naz from NB Network Lessons. Hope you guys are doing okay. My today's topic of discussion is circuit analysis lesson number 2. So today I'm going to try to introduce you to what alternating current and direct current are. I know you've heard the AC and DC in real life, but what exactly it means, I'm going to go ahead and try to introduce that. I would not go into details, but I'll introduce them because moving along to lesson 3, lesson 4, lesson 5, and so forth, when we dive into circuit analysis, then I'll touch more on direct current and alternating current. But let's go ahead and get started. So in your home, when you plug something into your wall socket, that's basically alternating current, okay? And then when you go buy a battery from CVS or any other store, that's basically direct current, okay? So what's the difference between alternating current and direct current? So if you have a microscope and you put it on a wire where the alternating current is flowing, it is like a sinusoidal wave, okay? So you have it like a sinusoidal wave, you have a peak, and then it goes up and down. So you've got one peak right here, and then you've got another peak right here. So that's your alternating current. If you put a microscope on the wire, you will see a sinusoidal wave. So now, why do we have alternating current? Because the scientists say, the theory is that when you're alternating or fluctuating the current, it pushes more in the wire. So if it pushes more on the wire, then the transmission of that to substation and then subsequently from substation to your home is much easier. A lot more happens in between, but I'm skipping that because this is just an introduction lesson. So this would be your alternating current, all right? And then what is direct current, okay? DC. So if you put a microscope on the wire, all right, you will see a straight line. This is your direct current. There's no fluctuation. It's okay to use DC in, like, for example, like a radio or a transmitter, a small appliance, DC current is used. Blood pressure machine, any other toys or anything, batteries, you buy them from the store, 9-volt battery, 1.5-volt battery, so they all have direct current. So if you looking at in United States, the frequency is the number of cycles per second, and the unit is hertz. In US, it's 60 hertz, okay? In other words, for alternating current, you have 60 cycles per second, okay? But in Europe and other nations, I think it's 50 hertz. But in US, we have 60 hertz, 60 cycles per second. Like I said, it's easier to transmit to houses. Power plants basically generate the AC. What they do is that they basically have a coil, okay? And then they rotate the coil around a magnet to generate the electricity. I will get more deeper into this, but this is just an introductory lesson. Another thing quickly I can go over is so this basically represents alternating current, okay? And you have current going in both directions. It's going in this direction in one cycle, all right? And then it goes in the other direction also. So you see that it's going in from bottom to top and then from top to bottom. And that is exactly what I mean by when I say that there is a sinusoidal wave, this right here. So you have a peak, positive peak, negative peak, and so forth. One common thing in your home is when you have a closed circuit. You know what a closed circuit is, right? Closed circuit is normally what you do is that when you have an alternating current, you have something like this, right? And what you do is that you have a light bulb, right? A light bulb right here is connected, okay? And then you have basically alternating current going through the light bulb. It's going in this direction and then going in this direction and provides energy to the bulb, and that's how light is emitted. What happens if you do directly like this, connect directly like this, make it a closed circuit, okay? That's a short circuit now, okay? So this is a short circuit. What will happen is that if you do a short circuit, they will basically trip your breaker in your house, because the breaker senses it that there is a short circuit, I need to trip. So what it does is that it trips and disconnects. So then you have to go back where your fuses or breakers are located, and you have to reset it, right? So that's what a closed circuit or a short circuit is. So I hope you like this. This was just an introductory lesson. I will come back and get deeper into circuit analysis. If you like the contents, please go ahead and give me a like. Thank you so much for watching. Have a good day.